For the lab, you must be able to convert grams to moles. I have already placed the sample mass of copper on this chart. We measured 108.20 grams in the sample using the scale. I do not want grams in my answer, and so we copy it to the bottom of the next column. Grams gets copied to the bottom. That will make it cancel out. Okay, I want moles, so moles gets written at the top. That is where the answer's unit goes at the top at the end. Okay, now that we have the units and the positions they're supposed to be in, now we can put in the numbers that we are supposed to have. In the notes, I have taught you, and I am still teaching you, that when moles is not in the given position, okay, the given position is here. That's not where moles is located. So I put a 1. Again, when moles is not in the given position, just write a 1. It works for our entire studying unit, this unit. Okay, now in the grams, where do I get that from? Okay, so this is going to be molar mass. And the atomic mass tells us the molar mass. Okay, the atomic mass tells us the molar mass. So when we see copper on the periodic table, okay, and we look at the atomic mass on it, that will tell us the number of grams that are in 1 mole of copper. 63.546. That is the molar mass of copper. So I have 1 mole of copper is made of 63.546 grams of copper. All right, we can begin doing this question. We can calculate it. Now, we always multiply the numbers on the top, and we always divide numbers on the bottom. Okay, now if you think about it, multiplying by 1 won't change any number. So it's optional. You don't even need to multiply by 1. It won't do any difference. Okay, dividing by 1 won't make the number change either. So you could actually skip that and skip that. All right, the part you have to do is 108.20 divided by 63.546. Okay, but I'll go ahead and show all of it in the calculator. Okay, just so that you see you could put all of it in if you wanted. 108.20, okay, times 1 if you want. Okay, divided by 1 if you want. And then divide by, you must do this part, divide by 63.546 equals. And the calculator's answer is 1702. Okay, notice I have 5 digits to keep. I have 5 digits in my given. I need to keep 5 digits. There's a decimal point there. I'm going to go ahead and put it on there. Okay, 1, 2, 3, 4. 1, 2, 3, 4. The 5th digit is a 7. Okay, and it was followed by a 0, so it gets to stay a 7. Okay, so 1.702 moles of copper. And abbreviation for moles is MOL. So there's the answer for the first example. All right, let's look at an example that is not even in the lab. Okay, magnesium nitrate is not even in the lab. In the previous video, I showed you how to calculate molar mass. Oops, wrong. In the previous video, I showed you how to calculate molar mass. We look at each element. We multiply by how many elements there are, or how many atoms there are. So like nitrogen is 1 times 2. Oxygen is 3 times 2. Okay, so 1 times 2 is 2. 3 times 2 is 6. If we add all that up, we get 148.313 as the molar mass of magnesium nitrate. So I will use this molar mass when the time comes. That's where we found it already. Now, I am pretending, okay, today's the 13th of the year 2001, so I totally made up this number. It's not even in the lab, okay? And let's say we got this mass in grams of magnesium nitrate using a scale. But you know I made up the number because it's not even in the lab. Okay, now, I do not want grams in the answer, again. So in order to get rid of it, what is here always gets copied down here so that unit will cancel out. I am canceling out the unit grams, okay? Since I'm canceling the unit grams, it's here and it's here, and that will allow us to cancel that unit, okay? Grams and grams cancels. Now, remember in this set of questions, I want to find moles. So moles will be the unit that goes here. You could put mole, or you could write the whole word, either way. Okay, now, when we're trying to figure out our numbers, we know that 1 mole, okay, 1 mole is equal to the molar mass. And remember, I just showed you 148.313. We calculated the molar mass of magnesium nitrate. We calculated it. 148.313. That's molar mass. Again, we may have to look at a formula to see how to treat the atomic masses, but the atomic mass tells us the molar mass, okay? The atomic mass tells us the molar mass. Okay, now we can calculate. Again, we always multiply any number that's on top. We always divide by every number that's written on bottom. Okay? And then, again, we divide by any number on bottom. Okay? You really do not have to multiply by 1 because it will not change the value of the answer. You really do not have to divide by 1. It will not change the value of the answer. But what you must do is you must divide by 114.313. Okay? So we can do 13.21. Okay, you can do times 1, divide by 1, but you must divide by 148.313, and the answer is, notice it's a decimal, 0, 8, 9, a whole bunch of numbers. Okay, look, 1, 2, 3, 4. I have 4 digits that I have to keep. Zeros in front don't count when we count significant figures, so I'm going to keep the 8, the 9, the 0. Now, the 0 is the 3rd digit. The 4th digit, when I count how many digits I wanted to keep, the 4th digit's actually the 6. It's followed by an 8. So the 6 will become a 7. So my final answer is 0.0890. And remember, the 6 had to turn into a 7. So that is now a 7. And again, the unit's moles. And it's magnesium nitrate. And that is a 3 here. Just wrote it kind of small. Okay. And again, grams cancel. We copied it down here so that it would cancel. Moles is not canceled, and that is how it ended up in the answer. And we're doing magnesium nitrate the whole time, and that's why it's magnesium nitrate here. Okay. Use this to help you assist in finishing the grams to moles calculations in the lab.